Resources, right? A lot of us go on Google, YouTube, Reddit, or anywhere else to find resources to how to become a better web developer, or maybe an Android developer, or if you are into iOS, maybe an iOS developer, right? But what if there is something that makes you a better programmer, right? What if it does not talk about web, Android, iOS, or anything else, but it talks about programming in its pure sense? How to make sense of it, how to develop or interpret or structure your program, right? So today in this video I'm going to talk about the book that probably you have never heard of, the book that everyone should read but is lost somehow in today's world. The book was written in 1980s by three professors from MIT, and this book is called Wizard of Computer Science, right? This book is called the Wizard of Computer Science books, right? And the book's name is SICP, a structure and interpretation of computer programs, right? And you may ask, 1980s, right? Like, how old is this, right? Where computers even exist back then? I mean, they did, right? We went to moon in 67 with kbs of RAM, right? So computers did exist back then, and this book talks about a lot of things that is, trivial these days, but makes you a better programmer overall, right? It talks about modularity, it talks about how to restructure your variables, your program, your functions, and all of that stuff. So now we will look at a chapter, or maybe a chunk of a chapter from this book, and see how this book progress. This book is like reading a sorcerer's book given to his apprentice to learn spells and enchantments, right? The book is like, let's say you are in Indiana Jones movie, and you are going through jungles to find ancient relics and souls and all that stuff, right? So let's get started. Building abstractions with procedures. The acts of the mind wherein it exerts power over simple ideas are chiefly these three: combining several simple ideas into one compound one, thus all complex ideas are made. The second one is bringing two ideas, whether similar or complex, together and setting them one by another so as to take a view of them at once, without uniting them into one which it gets all its ideas of relations. The third is comprised separating them from all other ideas that accompany them in their real existence. This is called abstraction, and thus all its general ideas are made. So the preface for this chapter is how we can take several ideas and combine them into one, and without uniting them, taking relation of to one another and building such abstractions, and how SICP interprets them. We are about to study the idea of computational process. Computational processes are abstract beings that inhabit computers. As they evolve, process manipulate other abstract things called data. And this is the best example or definition of data I have ever seen in a book. What is data? Data is something that is manipulated by computational process. The evaluation of a process is directed by a pattern of rules called program. People create programs to direct processes. In effect, we conjure the spirits of the computer with our spells. Whew, this line. In effect, we conjure the spirits of the computer with our spells. That's something I read for the first time, like, wow, this is something different. A computational process is indeed much like a sorcerer's idea of a spirit. It cannot be seen or touched. It is not composed of matter at all. Remember the example I gave about Indiana Jones, as you are going through several forest and jungle and finding ancient relics, and those relics have souls, right? The program have souls. We cannot touch them, feel them, but they are there, right? We know they are there. However, it is very real. It can perform intellectual work, it can answer questions, it can affect the world by disbursing money at a bank or by controlling a robot arm in a factory. The programs we use to conjure processes are like a sorcerer's spells. So I chant and spell, I make a program, I chant and spell, and that does something. That is a program, right? My process is a spell, and how it is conjured is by a program, and it does something, right? They are carefully composed from symbolic expressions in arcane and esoteric programming languages that prescribe the task we want our process to perform. A computational process in a correctly working computer executes program precisely and accurately. Computers do not think, or they cannot think. They will do as they are told to, much like the spell will perform the magic it is supposed to. It does not know whether it is doing the supposedly thing to do or what it should do. It is only doing what it is told to do. Thus, like the sorcerer's apprentice, novice programmers must learn to understand and to anticipate the consequences of their conjuring. Even small errors, usually called bugs or glitches in programs, can have complex and unanticipated consequences. If you guys are a Harry Potter fan like me, in the third book or movie, there is a scene where Harry is supposed to bring its Patronus, right? And even the slightest flaw in his concentration will not bring the Patronus and let Dementors have him, right? That is the example the author is trying to give here. I mean, Harry Potter was not back then when the book was written, but that even the small errors or the bugs or glitches can result in unanticipated consequences, can result in things that is not supposed to be there. Fortunately, learning to program is considerably less dangerous than learning sorcery. Yes, you are not going to get your hands broken or fall from a broom because you are learning Quidditch or something like that. It is a very safe sport to play if you call it a sport. Because the spirits we deal with are conventionally contained in a secure way, real world programming, however, requires care, expertise, and wisdom. A small bug in a computer aided design program, for example, can lead to the catastrophic collapse of an airplane or a dam or the self destruction of an industrial robot. Let's assume you are an aircraft engineer and you do something, right, which you're not supposed to. What will happen? The best case, nothing. The worst case, plane will crash, right? And we have witnessed multiple destructions in our history because of flaw in design, in computer program, in engineering. So real world is a bit dangerous, but learning it is very safe, simple, and secure. Master software engineers have the ability to organize programs so that they can be reasonably sure that the resulting process will perform the task intended. They can visualize the behavior of their systems in advance. That is called thinking. That is, let's say you are seeing a programmer, something, some senior of yours, and some really cool programmer that they know what's going to happen when they press the save button. When they do build the code, they know what's going to happen, if it's going to break or if it's going to work as it's supposed to. They know. And how do they know? Because they have the somehow mastered the ability to think in advance, to design in advance. They know how to structure programs so that unanticipated problems do not lead to catastrophic consequences. And when problems do arise, they can debug their programs. Well designed computational systems like well designed automobiles or nuclear reactors are designed in a modular manner so that the parts can be constructed, replaced, or debugged separately. That's what this book deals with. How to structure your program, how to interpret your program, how to modularize your program, right? And here I always think of an example called Ship of Theseus. And Ship of Theseus is, I think, the best example when you want to learn about modularity. It talks about a ship which is going through, let's say, repair, right? And in the duration of repair, you change every part of it, every bit of it is replaced. Is it the same ship or is it a different ship? Because every part of it has been replaced. And that's the power of modularity, right? You can still have the same thing, same result, but you have the power, you have the ability to change whatever you can or add new things. I hope you enjoyed reading the book along with me. This book is free. I'll put the link in the description below, and yeah, make sure to check it out. Make sure to read it. Yeah, that's it. If you like the video, feel free to leave a comment, share it, like it, subscribe to my channel. This is my first video. I'll make sure to upload a lot more things that I find interesting. And yeah, see you in the next one. Bye. Peace.